Hey everyone, this is Sagar Upadhyay from third year BTech in Cybersecurity and Digital Forensics, VRD Bhopal, member of Web Development and Security team of DSC, VRD Bhopal chapter. And today with me is Abhijit Chatterjee. Uh, and Abhijit, would you like to introduce yourself?
Hi everyone, I am Abhijit Chatterjee, second year student at VIT Bhopal University, currently pursuing BTech and CSE core, and I am a web team member at DSC VIT Bhopal.
Thank you. So today we are going to take a session on introduction to shell scripting. And if you are in any ways familiar to Linux and command lines and general terminal stuff, so you might have heard of shell scripting. And this is a very important and powerful tool to have nowadays. And it's always been so. So a shell script is, in short, just a collection of commands and sequences, just like you program anything, and it makes your work more effective, and it's just good to have tool, a strong tool when you are developing something. So we will start this session, and let me present my screen. All right, shell scripting basics. Now let's get started. So first of all, who this is for, or the basic requirements. So people with basic knowledge of Linux, some experience with terminal and command prompt is good to have, not necessary. Someone who wants to automate their tasks. So if you're already a developer, if you're already working, if you're already a student who is working with Shell and Linux for a long time, so it is a good to have tool to automate your tasks. Then someone who wants to create their own custom tools to enhance productivity. So we will also see how we can create our own custom tools for our own needs so that we don't have to type those long commands over and over again. So our goal at the end of this discussion or the session, we should be able to automate our workflow on Linux, integrate different modules and programs together, create our own custom command line tools, and of course, to be smarter than everyone else, more efficient than anyone else. Okay, so basic definitions. So before we start, because this is not a live stream that we have planned it to be, so we have some exercises at the end, and we are going to show some demonstrations too in between the presentations, and Abhijit will take over for the demonstrations part. So stay tuned to the end and make notes. If you want, take pen and paper and pause this video and go there, have something note down, because at the end of the video, we will give you two exercises, interesting, and something that will cover all of the basics that we will discuss in this discussion, and that will definitely help you. So we hope that you like that. So starting with the presentation again, basic definitions. Linux. Let's first understand what is Linux. So some people call it Linux or Linux, but it is not. According to the formal definition, it is Linux, and it is a family of open source operating system based on Linux kernel. So now, what is Linux kernel? It's very important because Linux itself is not an operating system, and we will see how soon. So we have different types of operating system built on this Linux kernel, and we call it distributions. Okay, so different kind of operating system targeted to different people are called distributions, or in short, we call distros. So this is what we mean by Linux distros. Distros is just short for distribution. So some of the most popular distributions are Ubuntu, Fedora, Debian, Kali, Manjaro, etc. Okay, OpenSUSE, Red Hat, etc. So we have these Linux distributions. So these are just operating systems which are built on the base Linux kernel, and with some modifications, of course, according to the need. Okay, so Linux is not actually an operating system itself. It is a kernel. What is a kernel? Kernel, let's just say, for in very simple terms, is the intermediate code between your hardware and your operating system. So every operating system is built on a kernel. Your Windows is built on a Windows kernel. Your Linux-based operating system like Ubuntu, Fedora, etc., is built on Linux kernel. So now, we will see how this is different and how this works in between these two things, like our hardware and the actual operating system that we use. So next is the Linux kernel itself. So kernel is a computer program that is soul of an OS. This is a very bookish definition, but what do we mean by it? So kernel is responsible for lots of low-level tasks such as disk management, memory management, and task management. Okay, so many of these things are needed for an operating system to function properly. So this is what is the role of a kernel. So let's understand. Okay, we have drawn it out for you. So suppose this is our Linux kernel. Okay, now we have a software stack. A software stack is just a collection of of different softwares. Okay, your word processor, your shell itself, and then different utilities that you have, your IP config, IN config, etc. Different utilities. So we call that a software stack. Let's say we have three different software stacks that run on Linux kernel, and then this software stacks can be mixed matched. Like one is focused for developers, one is focused for designers. So we take some from the designers, complete from the developers. So we call it, let's just call it a configuration. Okay. So we can have different configurations. Here we have two. One is my configuration that I use, and maybe you will use something else. So that would have your software stack on it, and the same base kernel. So this we can make from these different software stacks. So we will have, say, configurations. Now, these configurations are actually your Linux distros or distributions. So all my configuration, okay, everything that I have, everything that I need in an operating system, and I collected that over a Linux kernel. I can call it distro one, okay, Saket OS, Sackware OS, anything like that. Say Abhijit wants different things. Okay, he's a designer, if let's suppose, and he wants GIMP and Blender and different other softwares that is specific for his job. So he will collect these and run an operating system with those software, and that would have a different user base. So that would be distro two, distribution two. Okay, so this is a very basic term and a basic simple explanation. Actually, when we say Linux distributions like Ubuntu, they have the base kernel, but they also then modify it and enhance the base kernel according to their operating system. So they can add functionalities, they can remove functionalities, but the base is same. Okay, so everyone takes it from the core Linux branch in GitHub or any other control directory, and then they will add stuff in it and they will remove stuff from it to create their own operating system from that kernel. So that's why they are called Linux based operating system. Okay, they are based on Linux kernel, but they are not completely like Linux itself is not an operating system. All right, so now your kernel will communicate to hardware, and this is how it works. So I have some set of softwares that is dependent or that works upon a layer of Linux kernel or modified Linux kernel. I can add two, three functions in it, and then it will help my software to work with it. So there is a interesting story behind the origin of Linux kernel and the GNU software project. So be sure to check it out online if you want and search for GNU Linux history, and you will get to know the whole story about it and the revolution, we can say, of open source projects. Well, anyways, moving on. Then what is shell? So we all know this type of shell. Okay, shell is a calcium carbonate form a hard rigid structure over animals which save them. But for us, this is not what we want. In computing, a shell is a computer program. Okay, it is a program or utility which provides an interface to humans, that is us or the user. It can be automated program also. So to use the properties and the functions and the provisions of the operating system. Okay. The formal definition is, in computing, a shell is a computer program which exposes an operating system services. okay, your different programs, your APIs, etc., to a human user or another program. In general, operating system shells are either CLI, that is command line interface, or GUI, or graphical user interface. So if you are using Linux server with no desktop environment, and just when you open your computer, you will just see text, that is your CLI. And if you are getting any kind of graphic in your operating system, that is a GUI. So in Windows, Ubuntu, Fedora, they use GUI, but yeah, this Fedora and Ubuntu can also work on CLI, and there then you will not have your desktop environment, that is your genome and KDE, etc. Okay, so this is the basic definition of shell. Now, command line basics. Abhijit.
Thank you, Saket. Before we jump into shell scripting, we should know some of the basic commands that we need to know so that we can do a fine work in the command line essentials. Now, some of the commands which we need are next uh, cd, cat, mkdir, ls, chmod, rm, clear, and touch. Now, we'll see each of the commands in detail. First is a cd command, or also known as a change directory command. This is used to change the current working directory while working in the shell. The syntax of it is cd and uh, have a suffix at the end. The suffix can be of four types. Firstly, the path. Now, when we specify the path, the current directory is changed to the path specified. Then we can use the minus sign, which change the active directory to the last working one. Then we have the tilde that change the current directory to the home directory, and then we have the double dot that takes us one step back in the directory. Next is the ls command, or also known as a list command. This is used to list down all the files, folders that are present in the current directory. So it also has it is syntax is similar to that. It has ls then followed by a suffix. Uh, this can have five types of suffix. Firstly, can have no suffix. Then it shows the general files and folders present in the directory. Then we can have the ls path so that it shows all the directories in the specified path. Then we have the a. Now, what a does it is shows all the hidden items and folders also, which is not shown by the non no suffix one. Next, we have the dash L. This shows all the files and directories, including the hidden ones, along with the permissions, owner info, and many more details like size, etc. Now, the size of that is written in bits. So here comes the dash H suffix, which makes it easy to read using the KB, MB, GB, which we are more familiar with. Next is the mkdir command. This is used to create a directory within the current working folder. The syntax is mkdir followed by the directory name which you want to give it. Then we have the touch command that is used to create an empty file in the current directory. Uh, the syntax is touch file name dot extension. Dot extension is quite important as the Linux does not know which type of file you want to create. Then we have the cat. In basic, cat opens a file in read mode and shows us all the content. The syntax of it is cat a file name dot extension. Next, next is the chmod. Change permission. It is used to change permission related to particular files and directories. Now, what is permission? We'll discuss it later in the coming slides. Then we have the rm. It is used to delete the file in the current working directory. Also, the syntax is rm file name dot extension. And finally, we have the clear command, which is used to clear all the things that will come when we use these commands and make it all clean state. As for command dash help, you can use to get all the documentation about various commands to understand what they do and what are the suffixes they have in the Linux. And in Windows, there is help and then the command name. Next, we have the demo part. So I'll share my screen. Yeah, yes. Hope my screen is visible.
Yes, it is visible, Abhijit.
So let's start with the ls command. So ls, as you can see, all the folders and files in the current directory have come in, like their trial backup.py, backup.sh. Now let's try ls-a. As you can see, there are dot files to mention now. These are the hidden files which we can use. Now there is the ls-l. As you can see, there are multiple things like r, w, r. So don't be confused. I'll explain it later what these all mean. As you can see, the sizes are also given in 4096 bytes, 995 bytes, along with the name and creation date. That's too much info. ls-h. Next, we have the cd command. Like I do the cd try here. That's the directory that we have. Just a sec. As Linux is what you case sensitive, so we have to give the exact name. Now I am in the trial command. As you can see, all the four files and folder are visible here. Then we go, if we give the cd dot dot, we go one step back. And again, now we can do one thing more, that is cd home hash. As you can see, I have specified a path and it takes us to the that part. Now let's skip ls. As you can see, there is a subfolder present here. Now let's try creating one more folder, mkdir subfolder 1. Now let's try ls. As you can see, the subfolder 1 is created. Now this is the what mkdir does. Now let's try the touch command. Touch, what should we do? Log file. Let's see it out. Uh, the log.log file has been created here. Now, if we do like cat backup dot win dot ps1, see it shows all the files and folders like present in here. Now the screen is all filled up, so let's try clear. As you can see, everything is cleared up right now. Next, we have the rm command. Let's try ls once again so that the changes are visible. Like we use rm 4.txt. See, the 4 is gone. So these are some of the basic commands that you need to get started with your shell scripting and navigate your way through the shell. Now, next will be taken over by Saket.
All right. Thank you, Abhijit. And let me share my screen again. Just a second. Okay. So, um, continuing. Next, we have Linux and its file structure. So, Abhijit.
So in Linux, file is everything and everything is a file. So in Linux, files are stored in a single rooted hierarchical file system under the root, as we can see in the figure beside. That there is a hash, there is a slash root directory under which it has multiple subdirectories. Also, Linux is a case sensitive language. So if you write root with a small r and a capital R, they are two separate identities, like I showed in the demo when I used trial. So next we have the file permissions, as we discussed. As Linux is a secure OS, so every file has a permission attached to it, and Linux provides complete control over what permissions to give and whom to give. Like when we used ls-l command, we saw something like rwx, rw- minus minus x, and something like. Now, what does rwx means? R represents read, w represents write, and x represents execute. These are the permissions that are provided to a particular group. Now there are three types of group: user, group, and all. Next. Now the file permissions can be specified in two ways. First is the individual file permissions. In this, we use the rwx, r, and these commands for the user, group, and others. The command structure is written like chmod. Then we have either u, g, o, or a, which represents user, group, others, and all. And then we have the three uh, signal operators like plus, minus, and equal to. Plus is used to add permission to the existing permissions. minus is used to remove the permissions from existing, and equal to is used to reset the permission to what is given in the parameter. So some examples are chmod g is equal to r for file name. It will set the group permission to read, and all other permissions will be removed. And there is a minus x, which removes the permission execute permission from all. And then we can also specify different permissions for different group using uh, comma and separating them out. And if we use provide nothing in the after the equal to sign, all permissions are revoked from the particular group. Next is the numeric file based permission system. As the previous one was quite cumbersome, that we have to take care of 9 characters, there was introduced the numeric files permission, in which we have to type only 3 digits. Now the 3 digits also refer to the user group and others. Now what do each of the digits represents? uh, Now this is the tables which shows 0 represents that is no permission, 1 represents execute only permission, and 2 represents write only permission. And the rest of the permissions are a combination of these uh, atomic instructions, like 3 is equal to 1 plus 2. So 3 means write plus execute permission. Now 4 is also an atomic permission which represents read only. So now the rest is a basic maths, like 5 is equal to 1 plus 4, which gives read plus execute. 6 is equal to 2 plus 4, which gives read plus write. And 7 is the 1 plus 2 plus 4, which gives read, write, and execute. That is all. That if we want to provide all, we use 7. Next is shell scripting basics, which will be taken over by Saket.
All right. So with that being discussed, and we hope that some of you might already know the basics of Linux command lines. If you didn't, there you have it. Now we have a shell scripting basics, and here we will discuss and build a foundation for our shell scripting before we go to advanced things. So first of all, working of a shell. So as we discussed, that shell provides an interface to the user to interact with scripts, programs, and OS functions and kernel APIs. This was the definition in the introduction of shell that we discussed earlier. So what this means is, here we have screenshot of an example where I typed a random command, which is not actually a command, in Windows PowerShell. It is a shell, PowerShell. So then it says that the term command ulala is not not recognized as the name of a commandlet function, script file, or operable program. Why I only use Windows PowerShell to depict this? Because Windows uh, gives you this nice little thing, you can say, okay, and in Linux it will just say command not found. So I will not be able to show you what exactly the shell does. So here we can see we have commandlet. That means if you type anything in shell, it will search for any existing commands, any existing declared functions, any operable program. That means executable program. In Windows PE file structure, it can be exe or DLL or something like that. Or in Linux, you have ELF, executable. So it can be that if it is in path variable. So we will talk about variables soon. Okay. So this is the basic, very layman diagram of how we should visualize shell. So we have our kernel and operating system as orange. Okay. Over that we have our shell program. Okay. It is not directly over kernel. It is over your kernel and operating system at all, or like both of them. Then we have utilities built over shell, and then we have user, that is our space. So when we say any command, when we send any command, the shell will act as an intermediate, or it will allow us to use the APIs or functions of kernel, and it will also allow us to use the utilities that we have in our operating system or computer. Okay, so here's a small doodle that I made to explain how it is. Suppose we want to make a new folder. Okay, so we give a command to the shell. All right, shell will respond. Then the shell will tell this to kernel in a specific format. Then the kernel will execute a set of code that is inbuilt as a function in kernel, and the API which is invoked by the shell will be used here. and then the shell will reply. Okay, this is how it works. We say to shell, shell invokes the API in the kernel or the program, and then it returns the value, and shell will tell us what is the value. So types of shell. So we have burn shell, and then we have different variations of this. So here you can see one familiar name, bash, okay, and sh. So when we generally use a Linux operating system, you have heard of bash, okay, or sh. So slash bin slash bash or slash bin slash sh. So these are the different types of shell programs. So as we know that shell is a program, so these are the different types of shell available. Personally, I've never used C shell, C shell, or like the corn shell, but ZSH, SH, Bash, and POSIX we have used in like multiple scenarios, and we use it daily for our developer purpose. Like these are the basic shells. If you use different operating system, the provider of that system, the developer of that operating system might actually use a different shell according to the type. Okay, the advantage of C shell is that it works on syntax similar to C programming language. So people who are familiar to that will not have any trouble migrating to this. So this is the main reason that this was created. Okay, so well, the more you know. Then we have the advantages of shell. So apart from the biological advantages for shells for octopus and fishes, in for us, we also have advantages like fast automation, minimal prerequisite. That means that uh, shell does not need many of the baseline, um, you know, uh, utilities to work. It is a core utility in itself. So you don't need to install so many things before you can use shell. It is the core utility. It will be there always. Then works mostly everywhere, and effective communication with core utilities of OS. So instead of you typing the whole API and the large syntax of your API calls, you just say small keywords like make directory, change directory, and list. So these kind of things. So it will do the heavy lifting for you, and you can do your work faster. All right. So structure of shell script. Okay. So path to interpreter. This is a basic structure of shell script. So path to interpreter is when you start coding a shell script, okay, or a shell file. So initially, it is good practice. You don't need to do it like it is not required, but it is a good practice to define a path to interpreter. That means the path the interpreter, that is your shell program, is in, which will parse this shell script. We will see more on this, and you will get to know what we mean by it later. Then commented information about the script. So it is a good, again, it is a good practice to create a commented information. That means you can comment down certain parts of and write like about your shell script, what it does, what it is supposed to do, and how to use it, like that, so that people who are going to use it, if they open and see, they should be able to understand what it does. Okay, otherwise it is no different than a malicious script. Okay, then error handling, that is of course optional, and but it is again a good practice to include error handling. So if your program or shell throws error, how you handle it? Do you crash? Do you redirect it to somewhere? Do you redirect it to zero file or null file? Different things you can do. Then the code. This is not optional. This is pretty important, and this is the main thing. You code, and we'll see how you will do it. So a good, very simple example is this. Initially, the path to interpreter, we write hashtag, exclamation mark, then path to our interpreter or shell, that is bin sh. Okay. Then we write comment below it, like author, that can be your name if you wrote this script. Then anything, okay, this is pretty important. So You see, the comment is also starting with a hashtag, but the declaration of interpreter is also starting with a hashtag. So this is pretty interesting that the first line is not a comment in your, shell script. Okay, the first line, if it starts with a hashtag or pound symbol, it is defined to be a part to interpreter. Okay, when you say hash and then exclamation mark, it is a part to interpreter. Okay, so that you need to keep in mind. After that, everything you write after hash will not be executed by your shell, and it will act as a comment, of course. Then after that, we have code. Okay, in here we have script that error handling part because we don't need it for this. So we have code and we have a command echo. Echo will print anything on screen that is given to it. So it will print what is your name. Then read. Read is a command to take input. So we take input in variable person. We will see more about these variables and how it works later. This is just an example. And then we print this echo hello person. So it will be printed. Okay. So we will see actually the commands and the shell scripts in action in live demonstration. But for now, this is your structure and this is how it looks like. Now, variables and operators. Okay. So variables, the name of variable, this is a basic rule that it should be from small a to z or capital A to Z, numbers 0 to 9 or underscore. Okay, anything beyond this is not considered a variable and it is a violation, so it will cause error or it will not work as expected. It will give you runtime error, etc. Okay, so declaration is like you define a variable by placing variable name, then equal to symbol. Equal to symbol in any general programming language is a symbol which will associate the value after it to your variable name. So equal to, then your variable value. Then to access the stored value of this variable, you prefix its name with a dollar sign. Okay, so something like this, like we did earlier. Okay, let's see what we did earlier. Okay, in here, what we did was in here we read a variable person, and then to use its value, we put dollar sign in front of this the variable name. So here it will print the name. So let's do it. And I'm using PowerShell, and we will use WSL to go into Linux. This will work directly on Linux too. So let me open a Linux shell. Right. Okay. So what we did was echo hello. All right. So it will print hello. You can see here it will print hello on the screen. I think we can zoom it. Okay. Yeah. Now, if I give a variable name, let's say var one, we can use letters, capital letters, and numbers. And I say that this is uh, socket. Okay. So if I do this, so we can do echo, then we can add those, and we can go hello, and then var1. So it will print hello socket. Okay, you see. So this is how we define a variable name, and then the value, and then we can have this. We can use the variable by using this symbol. All right. So back to presentation. Where was it? Yeah. Then variables and operators. So we were discussing about variable and how to use it. Next, this is an example. Okay, another example is we create two variables x and y, and then we put values, and then we calculate the sum of the variables in another variable sum, and then we print sum. Okay, it will print the value of x and y is equal to that value of this sum. What is expr and how this works, and what is this backtick, we will see. Okay, what is this, what is expr, and what is this backtick, we will see now. So this backtick is a escape character, and this plus sign is an operator. So with this, we move to our next section, that is operators and operations, how we do it. Okay. But before that, let's talk about types of variables. So we have scalar variables, we have vector variables, then we have local and global variables, then we have shell and environment variables, and then special variables. So scalar and vector variables, what do we mean by it? Scalar means simple terms. Okay, we can have um, 1, 2, 3, 3.5, 6, a string. This is a scalar variable. A vector is a list of, you can say, coordinates. It's a list of your values. So a vector variable would be x is equal to, in bracket. So let's say f is equal to, in bracket, 1, 2, 3, etc. Okay, so this will be your vector variable. I forgot my digital pen today, so bear with me. So all right, and this scalar variable would be y is equal to 2.3. This is simple, a single value, and this is a set of values, so hence vector. And local variables means the variables which are defined specifically for a function. Okay, this will work inside a function, and global means this will work in overall your script in your shell. Then you have shell variables. That means the variables which are only defined and used in one instance of your shell. That is, when you open a shell, you type something, you have a variable. If you close the shell and you open again, it will be gone. Okay, and environment variable means that the environment you are using your shell in, it will have certain variables, like your path variable is an environment variable. So it will contain, like the path variable contains all the list of locations where there are binaries which you need to execute via shell directly. We will talk about it later also. It is also exercise for you. So this is your environment variables, and then we have special variables. So what are special variables? Here's a list. You can, like, this will take a lot of time if we discuss each and every one of these. And so we put a table. You can pause the video here. You can try them out, and you can read it out, and then you can continue with the video again. So for example, if we say the first variable, it is true with your C and C++ programming language also. Your first variable is the name of your current program or current file name which is executed to run that program. Okay, so that is $0. That is your very first variable. Okay, from $1 to the n number, it is the variables that are passed to the script or the function. Next, we have $hashtag. It is the number of arguments supplied to a script. So if the script, in a script we give it 10 arguments, and when then we type this, it will give us the number of arguments that are supplied. This will be also used in your exercise at the last of the presentation. Then we have dollar asterisk. That means if a script receives 2 arguments, then dollar asterisk is equal to the concatenation of these 2 arguments. Okay, $1 and $2. All right, we will. You can try this out and see how it works. It's pretty simple, and so on and so forth. And the similarly, dollar exclamation mark is the process number of the last background command. Okay, so these are special variables. These are different than your usual variables. You cannot redefine them, and they are used for a specific purpose in your system. So they are special, hence they are special. All right. Now, operators. The basic operators we have arithmetic operators, your plus minus divide, relational operators, which will define a relation between two entities, we will see. Then Boolean operators, true or false based, like it will check, it will test for a thing, and if it is true, it will return true. If it is false, it will return false. Then we have string operators, which will work on a string, which will modify, test a string. Then we have file test operators, which will work for a file. So we will check this out. So for arithmetic operators, we have addition, subtraction, multiplication, division, modulus, assignment, equality, not equality. Okay, so again, this is a big topic. You can pause the video whenever these tables come in, and you can read them out. And we encourage you to pause the video and read each one out and try to understand what it is. And you will see this expr and backtick, and we will discuss about it and we will see how it works. Similarly, we have set of relational operators. These will check or test the relation between two things. Okay, so if we see dollar $a dash equal or eq dollar $b, so this will result in the output saying true or not true based on the your result. Okay, your contents of those variables. If a is 0, b is 0, it will return true. If a is 1, b is 0, it will return false because they are not equal. Similarly, when we check for not equal, it will return true if they are not equal, and it will return false if they are equal. So just opposite of your equal operator. So similarly, we have others. You can test it out, and it is a good exercise to test these out as we list them. Okay, so it will help you remember them for much longer time. Then we have Boolean operators, pretty simple, three basic operators. We have a negation, logical negation, then we have logical or, and then we have logical and. So if you are familiar with any kind of programming language, you must be using them already. Not this specific notation, but the logic of these logical and logical or. But if you want to check it out, you can check it out in uh, the shell itself, and this exclamation mark will help you in the coming exercise also. Next, we have string operators. So string operators check for certain things in a string. Okay, when you pass a string, so equal to checks if the string is equal. This is combined with if else, which Abhijit will cover just after this um, section. And then we have not equal to, we have zero size check, and this, where's my cursor? Okay. This zero check is important for an exercise that we will discuss later, so keep this in mind. Then we have checks in the string for non-zero size. So if it is non-zero length, it will return true. So if you have some content in your string, so you can also use this. You have to just change some sort of logic in your code, whichever suits your use. And if it will check if the string is not empty, and if it is empty, it will return false. So if you directly put a string in your conditional statement, it will check if it is true, it is filled with some content or not, or if it is not filled with some content, it will return false. Then this is a lot. Pause the video and check this out. But these are the file test operators. This will check for specific files and things. This will not be used by you if you're getting started in shell scripting, but it will be used when you are doing some advanced shell scripting, or when you want to modify, or when you want to automate certain processes, or certain major things or critical things in your Linux computer. So then you will need to do this, and this will make your life easy. You need not to specifically use them. You can make your own function, but this is there. So yeah. All right. So now we know the operators, so that we can directly use them in the shell script, right? Well, actually, no. You see, uh, your shell does not have addition or subtraction operator inbuilt. Okay, so we have to use a different program. Okay, that program is called expr, or evaluate expression program. All right, so you might have seen earlier that we have used this statement: sum is equal to backtick expr, and then we type x plus y, and then we close the backtick. All right, so these are the properties. Backticks escape sequence. So everything you type between the backticks is evaluated by the shell before the main command. Okay. So this section is evaluated first, and its result will be then used in this main overall command. That is, your sum is equal to something. All right. And expr is a program which evaluates the expression. So here we see how we integrate different things in our shell. So we initiate this escape sequence. We then execute a command that is expr command, command that means a utility. We use this utility to calculate the sum of these two variables, and then the result will be replaced with this expression and will be assigned to some variable. Okay, now do it. So let's try to do this and let's try to see if it works. So let's say I say where x is equal to and where y is equal to 3. Okay, let me done. All right, night mode got off. Okay, so if we try to do this, something like that, echo, so we do where x plus, then we do where y. This will give us exactly what we typed in, 2 plus 3, but this is not what we want. Okay, so instead of that, what we will do, we will use backticks. Okay, so we will use echo, then x plus y is equal to, we will use backticks, we will use expr, then we will give our expression here. Okay, so we'll go where x plus, then we will go where y, and then we close the bracket. Now here we will get the result of 5. Okay, now how we get it, because this um, is our uh, program. It is a program. expr is a program, so even if we type it directly, if I type this directly like uh, expr where x plus where y, it will give you 5. But to use it in a echo statement or a string, the overall result, so um, we can write something like this: sum of x and y is equal to 5. So this will evaluate this command before executing this echo command, so that it will have the value of x plus 5 beforehand, and then it will print it. So we will get this result. Okay, I hope this is clear. You have to try to understand completely. And if we just type expr, we will get missing operand because expr is a program. So for any program, if you want to see more about it, you can type this command, that is manual pages for Linux and expr. And oh, okay, manual pages is not installed in my WSL, but you can always do the basic stuff, that is this help, and it will give you uh, a more you can say brief summary or explanation of the command. Okay, so back to our presentation. All right, Abhijit, what about conditional statements?
Now, first of all, conditional statements. Every programming languages need them. These are the basic things that are needed for them. So conditional statements, you must, if you have done any of the basic programming, you would know if else. So here there are if else too. So if else is the topic is same, but the syntax of it is a little different from what we had in the previous languages. As you can notice that we have an if, then we have a condition that is specified within the square brackets, not like the typical languages where we use parentheses, and also there is a space provided between. These spaces are quite essential, else the bash will not understand them and show as an error. Then the condition is followed by a semicolon, and then there is a then keyword, after which we have the statements which are printed when the condition is true. Then we have else, and then we have the condition where they are false, and then there is phi. Now what is phi? The then and phi, what you can say, are like the opening and closure braces for the if condition in bash. Now moving on to if else, elif and else. If there is same condition one, then we have to print. Then there is elif, which specifies the condition two, having the same spaces and the square brackets. Then we have the else part, and finally we close it using the fi. Uh, then we have the nested conditional. Then there we have the first condition, which is executed when there is true, and inside that we have a second condition. And how we specify the second condition is that we close the if condition in inner one with using the fi here only, and then we have the else one. So one if and one fi make one block. So this one becomes the inner block and this becomes the outer block. Uh, as I told, then behaves like an opening curly braces and fi behaves like a closing curly braces. Now let's test it out. I should present my screen now. Hope it's visible. Now this is the basic if else dot shell command. Uh, as specified by Saket, this is the shebang line which specifies the interpreter. Then we have the echo, which takes the input of a variable a and b, and then we use the equal to sign and print a is equal to b, else a is not equal to b. Sleep you can exit, ignore for now. It's used to pause the execution for a few seconds. Now let's test it out and what shall happen when we run the script. So if else dot sh. As you can see in this, CMD has executed and like we enter 20 and then we enter the value of b also as 20. So it prints a is equal to b. As the condition is satisfied, it prints that. Now let's test it out if its the condition is false. Like we use 30 and we use 40. A is not equal to b. Uh, Basic stuff which what happens in if and else. Now let's test it out the if elif else one. Now it uses the same thing. First the shebang line, then takes an input, and as you notice, the operators GT, LE, which we discussed earlier in the presentation, and this is the uh, logical operator AND. So what the code does is takes the marks and gives out the grades as per the marks. So let's test it out. Elif else dot sh. Let's enter the marks of A. Like assuming that I gave it 65. So it ends up printing grade C. Now let's see here. When the entered variable is less than equal to 75 and variable A is greater than 50. So then it prints C. Now if the variable A that is our marks is greater than 90, it should print S. Let's test it out again. I enter 95. It gives S. Well, we all need that. So this is how the if, elif, and else part works. Now for the nested if, we have a code. Now this shows the working of a typical username password system, though it's not that secure. And let's test it out then. Nested if dot sh. So just a sec. For this, we need to see the code as well. Now, as we can see that if the name is equal to Abhijit, then only it will ask to enter the password, and then it will check the password. The password check is nested within the check of the username. So let me enter the correct username. Then it asks for the password that is specified here pass. When both the conditions are true, then only hello is printed. Now let's test it out with some false inputs. So let's enter Avijit. That's the correct username. And let me enter a wrong password, like pass1. It doesn't execute the hello and goes to the else part of the inner block of the if and prints the wrong password, as you can see here. Now, if what if we enter false input in the first loop. So let's test that out too. Like I enter Saki. So it shows wrong username and none of them works. None of the inside code works. So this is how the nested if works. Now moving back to the presentation.
All right. So, um,
Just
yeah, I hope it's now visible. Yeah.
yes. So
Okay.
next important parts which each of the programming languages have are loops. Now why we use loops because we don't want to do the monotonous task again and again. So the common one comes the for loop. For loops and all statements between do and done are once performed every item in a list or number, that number range, that is the number of iterations we use for when the number of iterations are known. Now what are this do and done? Like if and like in the if and else we saw then and fi, the same task is done here by do and done. Like first we have the for, the variable, and in. What in does is works on a range. In the range here specified is first is provided by the starting index. Then we have the end value, and if we have the third value, that specifies the updation that we need to make. Uh, by default, it's one. Then we specify the semicolon, and then comes the do command. Anything inside do and done will be repeated as long as the for condition is true. But the for condition can also be used in a different way, like using the double brackets and using it similar to like the C++ or Java program which we do, like using the initializer, condition, and step, and then specifying the commands to repeat in the do and done part. The second one takes a condition for the input, while as the first one takes a range. That's the difference in both the syntaxes which we are shown for the for loop. In place of range, only arguments can be provided. As for the conditions, it can be anything which we use typically. Next we have is the while command, while loop. The while loop is used for when we have to iterate for an unknown number of time until a particular condition is satisfied. So we have a while, then we have a condition, and then we have a semicolon, and which is followed by a do and done. And between the do and done, there are command that needs to be repeated. Now, examples of example like where while can be used is to read the lines of a file, like each line in a separate. If you want to print each line of a file in a separate line, then we can use the while command. Now, next is the condition specified determination condition, and the command are the statement block. And then we have the new loop, that is until. Now, what is until? Until loop is used to execute the code until the expression is evaluated to be false. Yeah, that is, it's exactly opposite of what the while does. Like we have the until, then we have an expression. The code is similar to that of a while condition. Just in place of while, we use until, and the expression which is specified needs to be false for the code to run. Uh, this is the condition. Then we have the break command. Now, break command is similar like to that we have used in other programming languages. It is used to break out of the current loop that is executing. Like here, we can see that there is a for j is equal to 1205, which specified the number of items. Then we have the do, and inside the if condition, we are using that if the j variable is equal to 2, then we need to break it out. Else, we'll print it. So when j is 2, it breaks out. Then we have the continue command. Continue is used to skip a particular iteration of the loop and move on to next one. Like let's use the similar code which we used. Like the previous code, what it did was when the statement was equal to 2, it breaked out of the loop. But what this does is it will continue skip the current iteration and third move on to 3. That is third element of the list. Next we have the demo. Let's test out all of these which we have done. Share now. Let's test it out. So let's close these. Let's test it. Now for loop one, for loop two, while loop, and the until. So let's test out the first one, which we did. What this code will do is print out all the odd numbers between 1 and 20. As you remember the first syntax which we used, first we have the start initialization, then we have the end variable of the list, and then we have the step of how much updation should be made. So we have 1, and that 1 plus 2 gives 3, which is another odd value. So let's test it out this one. So first of all, let's clear for loop 1 dot sh. So as you can see here, all the odd numbers from 1 to 20 are printed, like 1, 3, 5, 7, 9, 13, 15, 17, and 19. So this is what, do remember to use this semicolon, because in most programming language which you have studied till now, either be you in first year, second year, or any above, which we typically use, we don't use a semicolon after the if conditions and the for conditions. But Bash script uses a little different logic. So do remember when you are coding in Bash. So let's see the other syntax which we did. Now, what this code does is first we have the shebang line, and then it prints the number that are less than 5 and greater than 16. So we have the initialization part here. Then we have the condition that I is less than equal to 20, and then we have the updation here. Remember the double parenthesis which I have used here. Then we have the do, which repeats the commands. Uh, when $I is greater than, remember the GT means greater than 5, and I less than 16. LT means less than. Then the it will continue, and else it will print the $I. So let's test it out. For loop dot to dot sh. As you can see here, it prints the number from 1 to 5, and then skips all the iterations that went from 6 to 15, and then again, when the condition of if was false, then it again started printing 20. So this shows how also shows how continue command skips the iterations. Now if we use break in place here, it should immediately break out of the loop when I is equal to 6. So let me save it. Loop dot sh. As you can see, after 5, the loop breaks and none of the command is run. So you can easily see the difference between if and the continue keywords here. If the screen was short, now it would be visible clearly. So that wraps up the if for loop. Moving on to while loop. Uh, what this code does is prints the number of digits that uh, number provided will have, digits in the separate line. So what we do is while $n, that is our input variable, is greater than 0, echo. Remember the XPR which Saket used. There is an alternative that to that also. We can use this another parenthesis set and use the expression we need to calculate here. This acts as an alternative to XPR, though XPR is a much better way to use. So, and then n is equal to n by 10. This is the shorthand operator for which shows n is equal to n by 10. So let's save it and let's run it. while loop dot sh. So let's enter a three-digit number like 951. So as you can see, the 1, 5, and 9 other digits and are printed on a separate line. And if we try to also print the updated values of n besides it, let me check. So we can see how the n variable is getting decreased on each iteration. Like let's input the same 951. As you can see, the 1 comes out and 9 becomes 9, n becomes 95. Then 5 is inputted and n becomes 9, and finally 9 is printed and n becomes 0. So this is how the while loop works. Now finally the new one in the batch, that is the until loop. Now it will print until and unless uh, it should print the value until and unless the I is equal to 20. So I have, as you can see, I have specified here and I is equal to 10. So the condition is not true at all. So it should run, like until command should run until loop dot sh. As you can see, the conditions are false, so their values are printed like 10 is not equal to 20, 11 is not equal to 20, blah blah blah. And then as you can see, after the done part there is written now I is equal to 20. So when I become, the condition becomes true, that is I becomes the 20, the loop breaks and the statements of the loop execute and print I is equal to 20. So as we see, until command run, until loop runs until and unless the condition is false. So that wraps up the loop. Moving on to next part. Uh, Coming back to the presentation.
All right, just wait a second. Let me present again.
Yeah, sure.
Okay.
Now, the next typical part of a programming language is functions. Now, functions are used to what you call group a particular set of codes which are used again and again and promote modularity. So, what is the syntax of creating functions in Bash? We can directly use function name, then the parenthesis and the curly braces, and put the commands of the function inside it. Now, how the arguments can be passed to the functions? We can use $1, $2, as we had discussed in the special variables. You can refer that if you forgot, and then we can access that in the functions inside. Um, Next slide. Next slide, please. Uh, like here we are. We can see that I declared a function like my func, and the empty braces. And what I do is hello and print the variables passed to it. So I pass my func, mass, and planet. So the two parameters here will be mass and planet. And again, I call the same function using Jupiter and big planet. These are the two parameters. And each time I return 5. Now, where will the return value be hold? Remember the question mark symbol, which used to give the return value of the previous command executed. Now, this will come here handy. The return value of here will be used using the dollar equal. And what this code will do is print hello Mars planet and my hello Jupiter big planet on separate lines. These are the parameters received, and all we can you can pause the presentation and see what each one of them means. Now let's move on to some example scripts. All Now, first of all, what we are doing is che- Now let's do some real world code, like why actually we use shell. Like we don't use shell for basic programs like we just saw. Now, what the objective of this code will be: ping multiple IP addresses and check whether they are up, running or not. For this, we'll access the ping module. Ping module is used to ping different IPs or URLs and return whether the IP is up or not. For more information, you can try it out the man and ping in Linux. Uh, let's there's all let's try it out first, then we'll move on to the next one. Hello. Let me clear this first. Now, first let's see how the function works. Now there are two ways to declare a function in Bash. The first one is using the function keyword and giving the function name and then writing whatever we need to put in the function. Else we can use this like the function name and the parenthesis. Now both of them have the same code written inside it. Right. So if one of them would be wrong, so it should give an error, right? So let's test it out. What the code will do is take two numbers, pass to the functions, each of the functions, and check the return values. See, the return value will be returned using this, as I am not printing here. So let's test it out. Function eg.sh. So enter first number. Let me get like take it 50 and enter the second number, that is 60. So this is the what the first function returns. The parameter paths are 50 and 60 and the return value is 110. Similarly, the parameter pass of the second function is also 50 and 60 and return value is 1110. That is exact same, which we needed. So both of the ways are used, which can we can use to declare the functions and do our task. Whichever seems better to you, it's up to you to use. Now let's move on to the actual code of the port check, which we did. Now, this is the beauty of Bash is that we can use the basic kernel functions and basic commands and the features provided to us by the kernel and integrate them in our programs and directly access them. So here's a function that is alive ping, to which the values will be passed, and it will use the ping command to ping the particular IP and check whether the IP is up or not. So if the default return value of commands when they executed successfully is 0, so we'll check that if the return value is 0, we'll print the node is up, else the node is down. Firstly, let's check out four sites, that is google.com, geekforgeeks.com, geekforgeeks.org, and stackoverflow.com. So let's test it out. Code check.sh. Sorry for the typo. Uh, Cool. As you can see, the return value is 0. That is the node Google is up. Now we received 1 for geekforgeeks.com. Now why geekforgeek.com is down? Because geeksforgeeks.com is actually a no site. It's actually geeksforgeeks.org, which is next, which is up, and then there's Stack Overflow. So when a site is not up and the return value is then the return value is 1 when the code is not executed successfully. So now let's test out something bigger. Like this is a random IP that I took, and I'll ping every single IP from 1 to 255 in this range. Seems it's quite a big task, right? Like uh, why this use? This is used by network admins to check whether how many IPs are up and running or not, so that they can create a check for it and automate this because pinging every single IP is a cumbersome task. So let's test it out. Uh, Actually, hmm. As you can see here that node 1 is up, node 2 is up, 3 is up, 4 is up. So these IPs are up and running here. So let's wait till we encounter a 1. See, it's pinging particular IP from 1, 2, 3, 4, 5, 6. See, we encountered a node IP.10 which is down here. So one value is returned. So this will go on till 255, that 192.168.1.255, and keep on checking every single IP and giving us the info. What usually the network admin do is they use a similar code, but they also integrate an email uh, function here to to ping each IP which is down, they get an email on their email specified that these IPs are down, which helps them easily check out the whole network easily in one go. So they just need to run the script once and they can check the IPs. So this will take a whole lot of time. So I'm closing it up. As you can see, so many IPs are up and running and only currently one is down. So let's move on to the next one. You can do many more things like this using bash script. So moving on to the next program which we have planned. Uh, so moving on to next. So port checking was quite an interesting task. So what's next? Next we have a directory traverse. Uh, Objective is to monitor a particular directory for changes made in it and log the details in a log file. For this particular one, I'll need to use Linux specifically because it uses a module that is iNotify tools, which is specific to Linux only. So just note down the commands that are sudo apt update and sudo apt install iNotify tools, because iNotify on some Linux systems may not come pre-installed, so we need to install it explicitly. So I'm presenting and the code here first, then we'll move on to the Linux execution. So firstly, this is the code. This is the code for the watcher.sh. Like first we take a path to the directory which we to monitor using. Then we would read. Then we create a log.txt. Remember the touch command which is used to create the file. Here we'll use that. Then we use while true, that is an infinite loop. And then when we specify var is equal to, remember these, the escape sequences. Here it will be used. So I notify wait, r, q, that is read, and the path. So and the changes made will be stored in the var variable, which will be logged in that log.txt file. We can also use echo to write in the files directly using this. As you can, using this double write greater than. So let me copy it first, and let's move on to bash. So cd.ld to move back to the home directory, and then we have ls. Now let me create it. Touch watcher.sh, and then another thing that we need to see are the Linux has its own text editor, that is Vim. So there are two things. There are Vim and Nano, which I'll try to give a small demo here also. So Vim watcher.sh. Okay. So this opens it. Uh, Vim can seem a little complex to you because it doesn't give a much information about it. So when you have to write something in Vim, you press I. So you can see in the below, it enters the insert mode. And also in Linux, there is no control V, so we use right click. And as you can see, all the code has been printed here. Now, once you have done with the code that we need to write in the Vim view, press escape so that the is you can see at the bottom that insert is gone. And now the main problem is to exit the Vim. Many people face problems here, but it's quite simple. Just we need to print colon w and q, and it will save the file and successfully exit it. Uh, Now let's check out the permissions for it. LSL. Wait. Remember, see the watcher.txt, the rw minus, and none of them have a. Everyone has a read only. There is no execute permission for anyone. So let's chmod 777. That is provide read, write, and execute access to all. Watcher.sh. Now let's see. See rwx, and rwx. Now that's what this chmod command does. So now let's fire the script. Now in Linux, we fire shell script using dot slash and then the name of the script along with its extension. So let me see what was my test directory doing. So home abhijit, just a sec, hash test. So the watch is now established. Now let me open another instance of Linux. Just a sec, let me divide the screen into. So let me go to the test folder and do some things that should be logged, right? So first of all, let's see all the files that are there. So we have one backup.log.vm, PSP1, and blah 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 another folders. So let's first delete a folder, rmrf subfolder one. So type sorry, subfolder one. As you can see here, open isdr subfolder one log has been made, and when we do ls, the subfolder is not there. Now let's create a file. Now let's say touch2.txt. See, create 2.txt. Log is made. Now what we can do is let's create a directory, subfolder test. See, a directory is being created. And now let's delete a file also, rm3.txt. rm command which we discussed in the starting. Remove the files. See, the file is gone. Now we have made so many changes, and the logs are visible here also. But have the logs been made in the txt file which we created? Now let's test it out. We move on to the folder having the log.file, and then we do cat log.txt. Remember the cat command opens the log.txt file in read mode. See, all the logs that can be made are here. So some of the commands which I was testing earlier are also there, but these are the latest command. You can compare them using the side by side here. So pretty cool, right? Now, what else can we do with it? Well, if is there a use for this actual feature? Like what I had planned, uh, like it's somewhat made, not exactly, but what you can do is replace the the logging features here and add the git commands here, like git add dot, git push dot, git commit and git push. Now, what will it do? Like each time you make a changes to the file, it will automatically back it up to your GitHub. Pretty cool, right? You don't have to write particularly every time, like all the three commands regularly. So you can automatically back that up here using this command. So these are some of the uses that you can do with the shell scripting. So next will be carried over by Sakir. Let me stop my presenting. Over to you, Sakir.
All right. Let's shift the presentation. Summary and conclusion. So we have just, we went through a lot of stuff and we understand that it is not easy to, get grasp of everything at once. So we suggest you to go over this video like multiple times if you need to, and try the things out yourself. Okay, do it yourself, because without doing the practicals you cannot understand exactly what it does, and maybe we are wrong somewhere, we missed something. So you will get to know what we missed or where we were wrong when you do it yourself. And if you find something like that, just let us know in the comments and we will try to correct it out. All right, so what we covered so far, we we discussed about the difference between shell and a kernel, what they are and what do we mean by it. Then we discussed about shell functions. Then we discussed about advantages of shell scripts. Then we discussed about variables, environment, local, then scalar vector variables, special variables. Then we discussed about loops, for, while, and until. Then we discussed about functions, how to create your functions in Linux, how to give parameters, how to pass parameters, and then we discussed about operators and expressions. So not in a specific order, but we covered all these topics in this discussion so far. So a bonus tip or content for you. So this is pretty important, and we have two exercises for you to test it out. So to check what you grasped from this session. So the bonus content is about the command source and .bash rc file. So till now, let me just okay. So till now, we when we create a shell file, let's say uh, how we create it. Okay, we initially do this, then we do bin sh, then we say echo, and then we do hello. Okay, this was the basic command, I guess we had. Uh, we can also read name, and we can here do hello. All right. So let's make a complete program. Okay. So we save it to run it. So we give it permission of executable. So one more step for you is when you are giving permissions, don't give you don't usually give 777, because as Abhijit discussed that 777 will give you read, write, and execute permission to all the groups. We don't want that. We only want to give executable permission. We don't want them to write something in the file. This is a security perspective, okay, for things. So instead of that, we only will do plus x. Plus x means that we will add executable permission to the file and not the write permission. So if we just do ls la test.sh, you can see we have read write for first group, but only read for all other. But if I do chmod plus s, and then I will do test.sh, now if we see it, it's read, write, and execute for all other, and still we don't have write to all of the groups. So this is one thing you will keep in mind. It will just help you. It will show that you are concerned about security, blah blah blah. But now we can just run this. It will say to enter name. I can enter name, and it will say hello Saket. Another thing is, if suppose I want to create my own command, okay, I want to create my own, you know, something like, say, we said that Linux does not have addition. Okay, so if I do 5 plus 4, command not found. It doesn't have something like that. If we do echo 5 plus 6, it will just print as it is 5 plus 6. So we use two things. Okay, we use first expr, or then also we use in parentheses that Abhishek discussed about. But what about we create our own command in Linux which can add these two numbers effectively? Okay, so for that I have created one small program called calc.sh. So it is simple. We have declared a function. We discussed how to declare a function earlier. Then in that function, I have put this command of expr. So whatever variable we give to function, variable 1 and 2, it will print the sum of those. Okay. Then, yeah, that's it. And then we have subtract, and then we have ADS for something else. I will tell you what. Okay. So now let's quit this Vim, and if I run this, nothing will happen because we just declared some functions, but we never actually executed the functions. So here comes source. Okay, so let's try this. All right. So source executes commands from a file in a current shell. Okay, and read and write execute entries. So that means if I do source calc.sh, it will execute the calc.sh, and uh, its functions that are defined will be stored in the shell itself. So now if I do add 5 and 4, 4 or 5, it will return 9. Pretty cool, right? If I just exit this shell and I will enter again to the shell, and if I do add, it will say command not found. But I can add this command by using source calc.sh, and now if I do add, let's do same thing, no issue, it will give 14. If I do subtract, this is also one function that we defined, and we go 5 and 4, it will give us 1. All right, or we can do 3 7, it will give us -4. This is how we can create our own command. So here we have created a command called add, and we will give two parameters, it will add. So now this is not specifically useful in all the scenarios. You have your calculators and you can do many other things. But now here comes another thing: how to initiate your commands whenever the system starts. And here comes the result of bash rc. So if I list all the files in here, we can see there is a file called .bashrc. It is a system file in Linux in your home directory. So what this will do, whatever code is written in this bashrc command, bashrc file, it will be executed whenever you create a new shell. If I do cat.bashrc, you can see that here we have all these commands which set up the shell for you whenever you're going to use it. So it will set some variables, set some names, etc. This kind of you can say display, what to show, where to show. This will set up everything. Okay. Now what we can do, because this script, the file is run every time a shell is created, we can load our own code by using source from this file, and whenever we open a shell, we will have our command there. Okay. So initially, remember, if I exit this shell and if I reopen the shell and if I type add something to something, it will give command not found. But I want that whenever I open the shell, we should have this command. So what we will do, we will echo source. Now here we will use all the things that we have learned so far. So backtick, that means a new command, present working directory, then backtick close, then uh, calc.sh, and then I will close this, and then redirection to dot. Let's make it more complex dot bash rc. So now to understand this command, echo will print source. Now this is under backticks. That means pwd will be executed first. Pwd will give the present directory where I'm working, and then it will append character.sh to it. So it will print source, then the whole path of character.sh in the file. It will append to the file. Append means whatever content is already in their file will be there. It will just add one more line to it. That is our line. And in the file bash rc, if we press enter, we'll see nothing because it will not return anything. But if we uh, print our file bash rc, we can see at the end of the file we have this, our new source command. So if I just exit my shell and again load my shell, now if I do 5 plus 6, we already have this command loaded, right? This is cool. So you can create your functions, and you can add your functions as a command to your shell. And this function can be anything like IP enumeration function that we discussed, or the directory watcher function that we discussed. The whole program can be your command like this. All right. Now, now there is an exercise for you. So far, whatever we have learned, we have at last we discussed the latest topic that we discussed was how to create your own command in shell. So now what we want you to do is extend this AND function by everything we have learned so far, so that it adds the elements recursively. So far, it only takes two elements. Okay. If I do add 4 plus 5, it will do. If I do 4 plus 5 plus 6 plus 7, it will only add these two, and it will not print these. Okay. So now, what can be done? So here is a hint for you. You can check for the available commands or the parameters that we have given to the function by this small utility. Okay. Sorry. By this small utility. All right. So this is a string operator. Remember, this will check if the string is 0 or not. So this is the first variable, and if we convert this variable into string, if this variable is empty, that means the parameter is not given, it will set this value to true. So we will print false. This might be a little bit ambiguous, so we will just change this. Change this to what do we change this to? Empty variable. Empty variable, and change this to filled variable, something like this. So what it does is, if the variable is empty, the function will check and tell you that the variable is empty. That means the variable is not passed. And if it is passed, it will show true. So to check this, all right, to check this, let's see where we have declared this thing first. So this is declared in here. The function is called ADS, and this is the same code as we discussed. So instead of false, what we can do is no value given, or I got a value. That's it. So this is now more easy to understand. Now we will save this. Oh, sorry. Here's the backtick operation. This will escape everything. Yeah. Now we save this, and if I exit the shell, and if I reload the shell, my new script will be loaded. And if I do ADS, it will say no value given. But if I do ADS 4, it will say I got a value, that is 4. So now this is a hint for you how you can check for values. Now you also know that all the parameters given are stored in numbers like 1, 2, 3, 4, 5, 6, like that, and you already know how to use loops. So the hint is you can use for loop, and you can check for every variable by this method. And then if there is a variable, you can add it. Okay. Pretty much, I guess I just told you whole program, but you have to code it, right? So you will find some difficulties refer the presentation again, refer our discussion again. If you are not able to do anything, just Google it. Just Google your doubts, your you can say choke points, and you will pretty much get a easy answer for that. Maybe you will get a more advanced program for this. And next, one step further is that create a complete calculator program which can be called by any terminal. That means you will create a program or script which will define these functions of a basic calculator. Better be let it be a good calculator like add, subtract. These are the basic functions. You add square root or something like this, Euclidean distance, something like this. Then you should be able to call that just like this. Okay, add, subtract as a command from the terminal. So if you do these two exercises, we think that you will cover most of the topics that we discussed so far in this very lengthy video. Whatever we discussed, you will go through them once and you will get to know how to use it and when to use it and where to use things that we have discussed. So what you can do next? We have learned so much. We went through so many things, so many terminologies. What you can do next is explore more about this. Okay, this is just a tip of iceberg. There's so many complex code you will find for shell scripting, and you will be just amazed by the creativity of people, how they manipulate the utilities given in Linux for their own uh, workspace utilization. And you will see, and this is just the basic of your shell scripting. Now, implement some of these in your next project. So whenever you create a new project, try to automate your workflow. Okay. Create custom scripts, create custom commands like just we did. These were very, very basic commands. You can do many other things now. It's up to your imagination. And then create an automation script to solve the common problem that I'm new to Linux. I don't know how to do this. So when people come to Linux, they are intimidated by the number of commands that we have, the number of steps we need to do to achieve something. So if you are comfortable in Linux, you can automate those issues. You can automate those procedures for people who are new to Linux. So suppose I need to add a new wireless network to my, you can say, Linux distribution. So I need to IW config, then I need to give certain commands to add wireless networks. What you can do, create a script that will just ask Wi-Fi name, that is SSID, and its password, and it will do the rest. It will automate the procedure for adding a Wi-Fi network via terminal. Okay, so just like this, and when you do something like this in open source environment, it will create a good reputation for you, and you will give something to the community, and that's what all we want to do. Then this is for fun. Some of our teammates in web dev and security told us to add this. Do not try this on your production machine. Do not try this on your um, daily run computer. What you can do is you can type this command alias run alias cd is equal to sudo rmrf, and then you can try to change directory to any directory you want. Okay, you can do cd root or something like that. See what happens and let us know. And you will also get to know what alias command does. So again, do not do this in your production machine. Create a virtual machine or something like that, or you can just Google it. You will get to know what you want. Okay. So thank you very
As
much
for what
for
you want to
attending
do,
this session.
Saket, I want to add something. Like next, what you
Yeah.
can do is like what I made a directory watcher program in the Bash script. So try out exploring more of the shells that we have here, like Power that we like Saket showed PowerShell. Then we have C shells, and try implementing the same watcher in that also. The code won't be same as I told you that it was for Linux only. So try googling it and find out how you can do it. And that's all for from us side.
Yeah, I think that's all we already discussed for a lot of time, and yeah, so do it, learn new things, explore the domain, and we will be coming back with another topic from DSC, and we are a lot of things going on. There's the hack DSC going on, so if you watch this video during this time frame, do participate in it. It's a great event and it's a mega event of DSC also, and See you in the next video. Thanks.